Afternoon, everyone. Welcome to the Bulkley Valley Research Center seminar series. I'm hosting today from the traditional territory of the Gidimt'en clan of the Wet'suwet'en Nation. My name is Dawn and I'm the operations manager at the center, and it is definitely my privilege to host these seminars. They're always so incredibly informative and spark great conversation and great learning, and we are immensely grateful to the researchers and practitioners for sharing their knowledge and their time. And we are also immensely grateful to participants and our members who support the seminars and enable them to happen. Pleased today to be hosting Vanessa Foord. We heard from Vanessa quite a few years ago, and it was great to be able to invite her back and hear what's been happening more recently in terms of climate. We will also be hosting Vanessa in May in person in Smithers, and looking really forward to that. And today she is in Prince George. Vanessa is a research climatologist for the North area with the Ministry of Forests, and she's been studying climate trends and climate change impacts in northern BC since 2002. She has a Master's of Science in Earth Science from Simon Fraser University and a Bachelor of Science in Environmental Science from the University of Northern BC. And she's a member of the Canadian Meteorological and Oceanographic Society, American Meteorological Society, American Geophysical Union, and the Canadian Institute of Forestry. And probably currently she's freezing as she tries to walk her dog in Prince George because it's minus 25, and apparently Nanaimo's hogging all the snow. So thanks very much for making some time for us, Vanessa, and really looking forward to this.
Great. Thank you so much for the invite. Just checking that you can hear me okay, and that I'm pretty sure you already let me know that you could see the slides. Thank you everybody for joining today. I know it's hard to talk about climate change when you woke up to minus 30 like I did, or 23 centimeters of snow on the ground on the coast. Sorry, Evelyn. Yeah, I've learned because of climate change that our winters are a gift. And I know the ski community in the Smithers area certainly appreciates that, but I do as well. It's a lovely time to reset from some of the extreme conditions that we've been having in the summer in terms of wildfire risk and smoke, but also to recognize the services that the ice and snow we receive in the north bring to our other systems. So yeah, thank you for joining me on this wintry day. The picture on my first slide is if you are a ski enthusiast on Hudson Bay Mountain, you may have come across this. This is mine. It is part of a research weather station network that I run across northern BC. I think I currently have 46, so that's a lot. Yeah, and if you do happen to ski by, like Bill Myers did one winter, please take a photo and send it to me. And if you need the link for this data, please follow up, and I'll send you the link to the data if you would like it. Yeah, I'm just gonna talk and we'll take questions at the end, but if any sort of glitches come up, please somebody feel free to interrupt and let me know. So as Dawn mentioned, yeah, I gave a Bulkley Valley Research Center presentation a few years ago. I think I've done it a couple of times now since I've been in the position of research climatologist with the BC Ministry of Forests. And it's nice to give an update because it has been a little while, and I'm going to focus a lot on the climate conditions of 2023 and 2024, hence the talk of the hottest year on record again, because we've been really seeing some interesting things climatologically that I'm excited to share, both globally and regionally. We'll talk about some changes in the climate change trends, how natural variability plays a really big role globally and regionally, and then some information on recent drought conditions. As Dawn mentioned, I will be back in May in person. I can't travel to give climate change presentations. That would be pretty hypocritical of me, but I will be in the area for field work. So that presentation will follow this one, where I'll get into more depth on the regional climate change, as well as talk about some of my installations in the area and research on ecological drought, wildfire risk, and forest health. So let's get started. So you've probably heard that 2024 was the hottest year on record. 2023 was the previous hottest year on record. So again, hence the title. And the top 10 hottest years on records shown on the right have all occurred within the last 10 years. Actually, the last 12 years have all been the hottest 12 years on global record. So this graph comes from NOAA, the National Oceanic and Atmospheric Administration. The temperature anomaly for 2024 was 1.29 degrees Celsius. For 2023, it was 1.19, sorry. So we have seen these increasing temperatures. They appear to be accelerating because if you notice, the third hottest year on record, which at the time in 2016 was the hottest year on record, it was just over a degree, and you can see there's quite a big jump between that third hottest year on record and 2024, the new hottest year on record. And that's because we had a 14th month straight streak of record-breaking global monthly temperatures, June of 2023 to July 2024. So that was quite unprecedented to have month after month after month of record-breaking temperatures spanning 2023 and 2024. So this is looking at that data in a little bit of a different way. This is looking just at land. The previous graph was both land and ocean. Really, the discipline of climatology is just about summarizing weather data, and there's a bunch of different ways you can summarize it. Sometimes making an average from January to December doesn't really make a lot of climatological sense. So this one instead is a monthly 12-month running mean of global land average temperature anomalies. And I wanted to show this one because if folks are familiar with the Paris Agreement on Climate Change, which came into place in 2015, it had a goal of limiting global temperature increase to 2 degrees, with a recommendation that 1.5 is better. And on land, we've started to surpass that, unfortunately. So the first time we broke 1.5 degrees on land was back in March of 2016. And then we've just recently broke the 2-degree threshold just a few months ago. So, that's a little bit concerning, definitely worthwhile increasing our communication about climate change, noticing that these large temperature increases are occurring. So for average over land, the temperature anomaly for 2023 was 1.81, and for 2024, it's 1.98. So pretty large increases. And if you follow along in the media, you may have heard that the US just recently pulled out of the Paris Agreement. 197 countries have signed, and the exceptions now are the US, joined by Iran, Libya, and Yemen. So this is what those temperature departures from 2023 and 2024 look like spatially. Just to note that there is a lot of higher anomalies in Canada in the Arctic, which if you've seen me present, you've heard me say before, northern latitudes are warming at a faster rate than the global average because of the positive feedbacks associated with our loss of snow and ice. And that's why we see those accelerated temperature increases in northern latitudes. So you can see that the areas of greatest warming in 2023 and 2024 did occur in parts of Canada and the Arctic. Global precipitation is a lot harder to rank like we do with temperature. So this is a figure of 2024 global precipitation, also coming from NOAA. Hopefully you can pick North America out. It is in the top left, as you would expect it to be if you can't quite see that on your screen. And it's really hard to create a ranking, a year-to-year ranking with precipitation because it is so variable across the globe. We have measurement challenges. It's hard to measure snow in the northern latitudes, for example. And so it's kind of neat to look at it in this way. So where there isn't much green or brown, that's near normal conditions. If it's a light brown to a light green, it's about 1/3 of normal. So the light brown is 1/3 drier than normal. The light green is 1/3 above normal. And then those darker browns and darker greens are 1/10 below normal and 1/10 above normal for the dark green. So you can see that there's a lot of those dark colors globally, especially up in the Arctic. And this is exactly what we expect with climate change. Precipitation does also increase with increasing temperatures at these more northern latitudes. Again, because of those positive feedbacks associated with climate change at higher latitudes, but also because more precipitation can fall as rain, more precipitation can penetrate into the Arctic because of the loss of sea ice. The sea ice effectively in the past has blocked weather systems from penetrating into the Arctic, but with that retreat in sea ice, precipitation increases. So it's only February 5th, so there isn't a ton of stats out yet on 2024. So I'm going to step back and take a more in-depth look at 2023 because it was very interesting climatologically. So before 2024, remember that 2023 was the hottest year on record. Now, I did just mention it's hard to rank year-to-year precip. But with the advantage of satellite data in conjunction with instrumental observation, we can rank it going back to only 1980. But with our best available information, 2023 was also the driest on record for land, which is kind of interesting to note, as well as it was the most humid on record for land and ocean. So that's kind of confusing. It was the driest, but it was the most humid. And to make it even more confusing, it also had the lowest relative humidity on land. So I'll try to get this straight for you. The humidity is increasing because of something called the Clausius-Clapeyron relationship, which states that for every 1 degree of temperature increase, there's a 7% increase in the ability of the atmosphere to hold moisture. So the ability of the atmosphere to hold moisture goes up as our temperature goes up. And that's why we saw in 2023, during the then record hot year, that the moisture in the atmosphere did increase, but it dried out the land. So essentially, more moisture was sucked out of land areas and put into the atmosphere, and it wasn't replaced. So 2023 also had the lowest relative humidity on land because relative humidity is a function of temperature. And as the temperatures were increasing, there wasn't enough water available that could be evaporated. So the relative humidity meant higher relative humidities based on the higher temperature meant that the atmosphere could hold more moisture, but the land couldn't supply that moisture. And that's why it was record low relative humidity. Hopefully that wasn't too confusing. You might not need to know the physics of all that. But just noting again, 2023, hottest temperature on record, driest on record, most humid on record, and the lowest relative humidity on record. So pretty extreme. So that also translated to 2023 being the highest on record for area of moderate and severe drought, as shown on the bottom left here. All of these graphs I forgot to mention are coming from the State of the Climate Report in 2023, which comes out of the American Meteorological Society. And that's one of the reasons why in my bio, I like to list that I'm a member of these different organizations because they provide me with very valuable professional development and information sources. So record drought areas in 2023, as shown in the graph on the left. It wasn't the record for extreme that occurred in 2022. And then finally, 2023 had the highest on record land evaporation anomaly. So again, getting to that point of temperatures were so hot that the land evaporated a ton of moisture. That obviously relates to the area of drought conditions. And yeah, makes sense with the other trends. So just to sum up, 2023, hottest on record, driest on record, highest humidity, lowest relative humidity, highest area of moderate severe drought, and highest land evaporation. So it really was an extreme year, and I'm nervous to see what these stats look like for 2024. Also, something of note, and I'll talk about this a few times, is misconceptions in the media. I heard a lot in the media in this year and last year that some of this warming was unexplainable. And we really shouldn't be surprised by this. I don't think those media reports were quite accurate. Our greenhouse gas emissions have not gone down recently, and a lot of these positive feedback systems that we had been expecting with increasing climate change are now fully established, and we're seeing accelerated rates of climate change. So with the declining trend in land moisture because of these hot temperatures, it is also having an effect on terrestrial water storage because the evaporation and evapotranspirations are so high under these increasing temperatures. And while I can say that 2023 wasn't a record for this, thankfully, that's great. In Canada, in parts of Canada, it was. So that graph on the right comes from a paper that looks at year of minimum freshwater storage. And many parts of Canada and up to the Arctic saw 2023 as the lowest year on record of freshwater storage. Again, getting to that messaging that our increasing temperatures are leading to us to lose a lot of moisture and water in our systems. So the climate crisis that we hear about can really be a water availability crisis as well, which we hear less about because there's many places in this graph here that within the past few years have seen their year of minimum fresh water storage. So if you think back to April of 2024, which sometimes seems like it was just, a couple weeks ago, but also can seem like it was so long ago in terms of the conditions we're in now, where luckily we're not in drought, but in April 30th of 2024, we were in a pretty extreme drought condition starting the spring of last year. So this figure that comes from Agriculture Canada, comes from the Canadian Drought Monitor, which is a product of expert review that look at different climatological drought indices, soil conditions, agricultural conditions, expert review, and kind of come up with this ranking of drought conditions. So where I am in Prince George, April 2024 was in an area of exceptional drought. And areas of extreme drought certainly penetrated into parts of the Bulkley Valley, Skeena region, and there was lots of severe drought in that area as well. So if you're not familiar with the acronym I'm using on this slide, the SPEI, that's called the Standardized Precipitation and Evapotranspiration Index. It is an index of drought, but also an index of pluvial. So pluvial is the opposite of drought, and that means a very wet period. And this is one of the better indexes to use in Canada to understand drought just from meteorological data, because it does take into account the temperature and the temperature demands on evaporation and evapotranspiration, which is really important when we think about drought, because drought isn't just a lack of precipitation, it's also the moisture that's available after evaporation and evapotranspiration has occurred. So looking at that graph, which is centered around that area of exceptional drought in the map, so central interior, You can see that since 2010, we've trended towards drier conditions. A moderate drought is below the -1 line, a severe drought is below -1.5, and an extreme drought is below -2. So -2 before 2010 was not common for the central interior, but has been happening quite frequently since 2010. So spring was an exceptional drought, but it also was a persistent drought. So we've been in this condition for the long term now in the central interior. So switching from looking at those global conditions and the drought conditions, I thought it might be interesting to look at some stats just for BC. And this comes from BC's Climate Anomaly app. It's really cool. It's got a ton of climate information in it from 1951 to 2024. It was created by Dr. Aseem Sharma, who is also a research climatologist with the BC Ministry of Forests. Yeah, and it's just a fantastic tool if you haven't had a chance to check it out yet. The link is on my slide here. So it shows that 2023 was our hottest year on record in BC. It wasn't 2024 like it was globally because we have a lot of dynamics at play in terms of how natural variability also affects our weather and our climate conditions, which I'll talk about further in the in the presentation, not precipitation. Yeah, but you can see that we are having an increasing temperature trend across the province, no surprise. And again, that hottest year on record being 2023. I thought it might be neat to compare the top 10 hottest years on record for BC as compared to the global top 10. And I've highlighted in purple the years of overlap. So they are 2015, 2016, 2023, and 2024 for both BC and the global top 10s. Note, I am looking at different periods of record. The global record goes back to 1850 and the BC record only goes back to 1951. So the numbers for BC might not be entirely accurate, but it is interesting to note 2015, 2016, 2023, and 2024, they were all impacted by El Nino conditions, which can relate to warmer than normal temperatures globally as well as provincially. So here's an example of that, going back to that global record. Again, this comes from NOAA, where we're looking at those temperature anomalies over time. And now the El Nino months are imposed in red. The La Nina months are shown in blue. And when it was neutral, it's gray. So you can see 2016 and 2023 show up as quite warm in the global records, but then you can see that for 2024, those high temperatures occurred in the absence of El Nino. So we can't just think of one factor being what's causing these high temperatures. It's the combination. So at El Nino, we know brings warmer than average conditions, but in the context of climate change, this could mean an extreme year. One of the misconceptions with La Nina is folks say that it brings cooler than average conditions, but in the context of climate change, a La Nina year is just likely to be cooler than an El Nino year. We can't no longer say that it'll be cooler than average because we can't take out the impact of climate change on those temperatures. So if you're not super familiar with El Nino and La Nina, just a quick explanation. During El Nino, there's warmer than average tropical Pacific Ocean east of the date line and our trade winds weaken. But during La Nina, there's a cooler than average tropical Pacific Ocean east of the date line, and we have stronger trade winds. And I'll explain that in a little bit more detail about how it affects BC and northwestern BC in a few more slides. Pausing for a water break because I'm starting to get tongue-tied. I thought it might be neat to look at the last 10 years of record using that BC Climate Anomaly app. So showing here spatially what the last 10 years of mean annual temperature anomalies have looked like. You can see right off the bat that 2015 was quite hot, especially in the Okanagan area and parts of the lower mainland. In 2016, the hottest areas were really up north. In 2017, there was some relief, but the Northeast was quite warm. In 2018, kind of the reverse, parts of the Northeast had become quite a bit cooler, and there was a lot of warmth across the province. In 2019, conditions were split. The northwestern part of the province had the majority of the heat, whereas parts of the southeast and even into the central interior were cooler than average. In 2020, the northeast was cooler than average, and the rest of the province normal to slightly above. In 2021, now remember that was the year of the heat dome, but that was a short duration event. Looking at the annual temperature average, the north actually ended up being cooler than average, and then only parts of southern interior were warmer than average. In 2022, again, the Northwest was quite warm. And in 2023, you can really see that warmth spread across the province and especially concentrated in northern parts of the province. And then a bit of relief in 2024, but still quite normal than average last year. Now looking at precip, there is no statistically significant trend in precipitation for this record of 1951 to 2024. As you can imagine, precipitation trends across the province are extremely variable. We're a very large province. 2023, our hottest year on record, was also the fourth driest, but 2024 came in within the range of normal variability. And it was 2020 that shows that record year of wet on this trend line here. So again, let's look at each of those years specifically. So total precipitation anomaly for the last 10 years, 2015, there was some very dry conditions in parts of the Northeast. But then in 2016, that flipped over to the Northwest as being drier than average. 2017, again, the Northeast is drier than average. And then most of the North by 2018 was quite dry. Just following along with my notes here. 2018 was an interesting year. I recall that parts of the Northwest and Haida-Gwaii had their wettest years on record, but over in Fort St. John and parts of the Peace, it was, sorry, I think I said that backwards. So Northwest and Haida-Gwaii was the driest on record, where over in the Peace, it was the wettest on record. And I found that really interesting to have such a stark contrast between record dry and record wet within a relatively short spatial extent. So 2019, a lot of dryness around the coast, but parts of the interior were wet. 2020 was that record wet year across the province, and you can see a lot of that was concentrated in the central interior and parts of the Cariboo. In 2021, the Northeast was starting to dry out from that precip, but the coast remained wet. 2022 continued drying for most of the province, the exceptions of the Northwest. And then 2023, you can see quite a lot of drier than average conditions. Again, the exception of the far Northwest, but a lot of drying in the Northeast. And then that continued for the Northeast in 2024, but some relief was brought to the rest of the province last year. So the central interior actually ended up being a little bit above average, even though it started the year in record drought conditions. But getting back to what I was saying about evaporation demands with increasing temperatures, it's neat that this BC climate anomaly also has an index of drought. It has vapor pressure deficit information. So if you're not familiar with that term, it's the difference between the amount of moisture in the air and the amount that the air could actually hold when saturated. So when vapor pressure deficit is high, that means that the atmospheric demand for evaporation and evapotranspiration to occur is high. This can cause a lot of plant stress or loss of moisture from land and drought impacts. The VPD is also a good indicator of wildfire risk. So the highest vapor pressure deficit on this record, going back to 1951, did occur in 2023, which corresponds to our record worst wildfire season as well. So again, looking at each of the last 10 years, this time for vapor pressure deficit anomaly, you might be able to pick out some of those locations of bad wildfire years if you can recall those years in your memory. So there was quite a lot of wildfire in 2015. It was mostly concentrated in the southern interior and parts of the Northeast, and the VPDs certainly show that. We had some relief in 2016, but if you recall, the spring of 2016 was really hot and dry. That is when the Fort McMurray wildfires occurred, and there was a lot of wildfires in the piece. So it doesn't actually show up here because there was relief in terms of precipitation later in the year. But spring of 2016 was a significant wildfire season. There was quite a few wildfires, unfortunately, across the province in 2017, but showing here that the vapor pressure deficits were highest in southern BC, where the wildfires were concentrated the most. There was a lot in the Caribou that year. And in 2018, that was really the Bulkley Valley, lakes area, parts of Northwest, hotspot for wildfire, unfortunately, and that seems to show up in these VPD patterns as well for the Northwest. In 2019, again, we got some relief, although VPD was high in parts of the Northwest. 2020, pretty low VPDs, so lower than average vapor pressure deficit for most of the province. And if you recall, that was our wettest year on record. And then in 2021, that was the year of the heat dome, and it didn't really show up as anything special in terms of the temperature anomalies, but you can see that vapor pressure deficits were still quite high and extremely high in parts of the Okanagan, where there was quite a few wildfires. 2021, vapor pressure deficits remained quite high, even though this wasn't a super exceptional wildfire season. There was still, quite a lot occurring, but then 2023, our record wildfire, you can see corresponds to those high VPDs across the province. The Northeast and parts of the southern interior were the areas that were the worst hit, and that does correspond to those high vapor pressure deficit values. Those wildfires continued in the Northeast in 2024, which also corresponds to high vapor pressure deficits. And then there was notable wildfires in the southern part of the province last year as well. So wildfire risk can definitely be related to drought. We've done some work trying to look on if there are trends towards more likely drought conditions across the province. So we looked at that standardized precipitation and evapotranspiration index trends going back to 1950 and ending at 2023. And I'm just showing here some of the seasonal trends in that SPEI value. So the brown with lines means that it's statistically significant, but the brown is trending toward more drought. So you can see in that first map of BC, there's a lot of brown statistically significant trend for southern BC in terms of winter drought. We don't really think of drought in the winter, but this is really important to note because that winter precipitation is our storage for spring and summer. So it's very concerning to see these drought trends in winter months. Spring. Spring is a very variable season, so there are some areas of statistically significant trends scattered throughout northern BC in terms of pluvial, so wet conditions. But then parts of the Caribou, the Chilcotin Plateau, perhaps having some increasing in drought during the spring months. And in summer, this could look good, but really these areas of pluvial conditions are really concentrated at higher elevation, so the coastal mountains and parts of the central Rockies, where I think our higher temperatures are causing increased convective precipitation to fall in this part of the province. And then we see increasing pluvial for parts of the Northwest, which is kind of interesting. But the jet stream is also bringing any summer weather systems further north, and more precipitation is falling in the Northwest than in other parts of the province. For those folks that could be joining us from the coast, there is some statistically significant drought trends for parts of Vancouver Island and parts of the Lower Mainland and parts of the interior. And then fall, again, the weather is so variable, it's hard to get statistically significant trends, but there is a signal towards drier conditions for parts of the Northwest in the fall and statistically significant drought trends in the Prince Rupert area. So looking at some longer seasons, so the first map is showing what's occurring during our cold season, so October to March. There is a statistically significant drought trend on the island and parts of the interior. And then during our growing season, April to September, a statistically significant trend towards pluvial conditions in the Northwest. But it isn't as simple as that. When you look at individual months, you can pick out some other trends. So when we look at just June, more of those pluvial conditions pop up. In the interior, June tends to be the wettest month, and this seems to be increasing. But in October, that's where we find the increased drying conditions. So it seems to be our summers are kind of extending into the fall months and causing increasing drying conditions in the month of October. Okay, so trying to narrow this down a little bit more in terms of those regional changes, looking more at what's going on in northern BC and even picking out a few weather stations like this one for Fort St. James. If you've seen me present before, I do rely pretty heavily on this long record that goes back to 1895, as it is the longest continuous record we have for northern British Columbia. The trend over 1895 to present for mean annual temperatures is 3.4 degrees. So that's a very large increase over time, much larger than the global average. Over this time, we do have a statistically significant increase in precip, so that's good. There's been no change in extreme maximum temperatures for this area over this period of time. But in terms of our extreme minimum temperatures, so those really cold conditions, there has a 7.5 degree increase in extreme minimum temperatures. So this is where most of the warming is still occurring. It is occurring during the winter months, during those cold times. And while I mentioned I woke up to -30 this morning, it could have been -40. So we are seeing those increases in those super cold temperatures, even though we don't like to experience them. And then for this nice long record at Fort St. James, 2023 was the hottest and the driest on record, just like the global conditions. 2023 was extreme across northern British Columbia as well. I found this really interesting. I keep track of when a weather station in northern BC is in the top 5 of a monthly or seasonal climate ranking. So if it's in the top 5 warmest or coldest or wettest or driest, I like to make a note of that. And I've just compiled all the information for each of the weather stations in the north. The data does come from Environment and Climate Change Canada. I've just compiled it. And in any given year up to 2023, there's usually a handful of these across the north, but each of these weather stations had a handful of these in 2023. So very extreme conditions in northern BC. So Prince George, for example, 2023 was the third warmest and the second driest. December was the fifth warmest by 6 degrees. Fall was the fifth driest with only 48%. September was the fifth driest with only 27% of average precip. Summer was the driest at 47%, and May was the second warmest at 3.4. Over in Smithers, on the far right of this slide, 2023 was the warmest on record, and it was also the driest on record. So 1.7 degrees above normal, and only 61% of your precip fell in 2023. Fall was the third driest at only 52%. It was the warmest summer on record in 2023, 2.1 degrees above normal. August was the second warmest, 2.5 degrees above normal. July, the fourth warmest, 2 degrees above normal. And June was the fifth driest at only 25% of average. And May was the warmest on record in 2023 at 3.8 degrees Celsius. Now, I'm not going to read the rest of the weather stations, but if you look at some of the temperature anomalies, especially as you go further north, for example, if you look at Fort St. John in 2023, December was the fourth warmest by over 8.1 degrees. The temperature anomalies as you move further north are very large. So that 8.1 degree anomaly is very concerning, but there's quite a few that are above 5 degrees above average, 6 degrees above average in terms of these temperature rankings that occurred in 2023. If you're curious about what we saw in 2024 for Smithers, it was the ninth warmest, which was just over a degree above average, but it also continued to be dry, receiving about 100 millimeters below average precip, which ended up being the sixth driest. And then I don't have any stats compiled for January yet, but I did note that Fort Nelson just had its second warmest January on record for 2025, where it was 8.6 degrees above average. So very warm in parts of the Northeast so far this winter. So drilling down further to where I'm assuming most of you are calling from in the Beauclair-Skeena area, looking now at 2024 climate rankings. So Smithers in spring of last year was the second driest, receiving only 34 millimeters of precip, which was 41% of average. July was then the third warmest in Smithers, being 2.5 degrees above average, followed by August being the fifth driest, receiving only 7.2 mils of precip and 16% of its normal amount. But then the conditions changed. In September, it became the fifth wettest, receiving 97.8 millimeters or 82% of the September average. And that was due to mainly an atmospheric river that penetrated the area. I think it was between September 22nd and 24th, which brought about 50 millimeters to the area. And then the precipitation train, or the train of weather systems that occur in the fall, just started coming in one after the other. For Terrace, September ended up being the third wettest on record because of that atmospheric river. That area kind of took the brunt of most of that precipitation. And then in fall, it ended up being the third wettest on record. In Smithers, 146% of average, and Prince Rupert in December was the fifth warmest on record, 2.9 degrees more than average. It's also worth noting that for Smithers, winter 23-24 had the lowest maximum snow. The maximum snow depth at the airport was only 14 centimeters, where the average should be around 49. So very low snow year last winter. Looking at some trends in Smithers data, precipitation is decreasing in the winter by almost 39%. This record goes back to 1942. And only the bold values in this table here are statistically significant, so I'll just talk about those. So declining precip overall in Smithers, mean temperatures have gone up by 1.7 degrees. Most of this is occurring in the winter, then summer, then spring. Maximum temperatures have gone up by 2.5 degrees. Most of this is occurring in the summer months, so your hot days are getting hotter. Minimum temperatures are increasing, so your cold days are getting warmer, which is good, I guess, for some things. An increase of 3.9 degrees over this period of time, and most of that is occurring in the spring. So the coldest temperatures in the spring have gone up by 4.7 degrees. That winter decline in precip of 38.5% is probably due to a decline in snow. There is statistically significant declines in those maximum snow depths of minus 24.5% over the year. And of course, most of that occurring in the winter months of minus 32.8%. There's a lot of variability embedded in these trends. For example, August 2018 precipitation was only 1.2 millimeters, but then August 2020, it was 1.4 millimeters. So there's a ton of variability, and it summarizing this way doesn't really get to the whole story. So to show some of that variability, I rely on that standardized precipitation and evapotranspiration index again. This is a 3-month running average showing an area around Smithers on the top graph and an area around Prince George on the bottom. And there's some differences here. So if you look from 2020, 2010 on, you can see that the variability in Smithers seems to be increasing. So while it's normal for Smithers to move between times of high precipitation and low precipitation, Smithers really borders being on the edge of either a maritime climate or a continental climate. But you can see that those changes are becoming more widespread. So lower periods of drought and higher pluvials have occurred since 2010. Whereas in the central interior, we're trending towards more drought and less pluvials, which is kind of interesting. So there's this term hydroclimate whiplash that seems to be becoming more common, and Smithers is definitely in an area that experiences this. Parts of the Northwest experience this naturally, but it's becoming more frequent because of climate change. So short duration switches between high SPI values or pluvial and low SPI values or drought have been found to be occurring more frequently globally due to climate change and are projected to increase in frequency due to climate change. And so as the atmosphere warms, as mentioned, it can hold more moisture. And so this paper has an analogy of a sponge. So when the temperature of the sponge gets hotter, it can hold more water, but also when you wring out that wetter sponge, more can fall. So the extreme precipitation can occur. But then on the flip side of the dry conditions, as the temperatures increase, more evaporation and evapotranspiration occurs from the land. And once the moisture becomes limited, it just gets hotter and hotter because there's no relief from moisture. The soils heat up, the ground heats up, plants potentially die, and it just accelerates the warming. So that's why wet conditions are becoming wetter, dry conditions are becoming drier. And this paper recommends that we need to manage for both droughts and floods occurring within short duration of each other. So risks of going from extreme wet to extreme dry are decreases to water quality, flash drought, crop challenges, livestock mortality, enhanced risk of wildfires because first the plants grow during the wet, but then they dry fast during the drought conditions. And going from dry to extreme wet, then we get flash floods, again, water quality issues, pathogens, mosquitoes, other insects, debris flows, and again, challenges to our agricultural systems. So I know there's only a few minutes left. I just got a couple more slides and hopefully you'll be able to take a couple questions. This is a complicated slide that really just goes on to explaining how El Nino and La Nina affect our jet stream. And basically what happens in El Nino is the jet stream moves further south, and a lot of precipitation tends to miss British Columbia because of this. And there's a lot of warm air advection occurring across the tropical Pacific Ocean. So that's why we get generally warm, dry conditions during El Nino. But in the reverse phase, La Nina, the jet stream starts from a location that's further from British Columbia, but it ends up being pointed right at us. And while it's a moisture-laden jet stream, once it hits the North Pacific Ocean, it becomes extremely variable. So during La Nina conditions, we have a variable jet stream. So we can be under extreme hot conditions. Think of the heat dome that occurred during La Nina years. We can be under extreme cold conditions in La Nina years. We can have periods of a lot of moisture, but then we also can have periods of drought. And the Smithers area especially is quite statistically significantly related to the Pacific Decadal Oscillation. There's positive warm and negative cool phases associated with this oscillation as well. And how this works is during the positive phase, sea level pressure is below average in the North Pacific. Sea surface temperatures are cool in the interior ocean, but warm along the coast. So basically, this generates more frequent low pressure systems to BC, especially the northwest of BC, with warmer advection and wetter conditions. But in the opposite phase, the cool phase, the sea level pressures are above average in the North Pacific, but the sea surface temperatures along the coast are cool. The flow is northerly, and this generates more frequent high pressure systems to BC, leading to drier conditions and colder winters, but also hotter summers. So we've been under the influence of predominantly negative or cool phase of the Pacific Decadal Oscillation since 2017, but even extending back to the early 2000s that have led to a period of relatively drier than average conditions. And we're currently in a cold phase of the Pacific Decadal Oscillation, sitting at -2 with no indication that it's going to change. So I only had 2 more slides on projections, but maybe I'll just leave it at that because I do want to have a couple minutes for questions. So we won't talk about how this might get worse in the future, but it's good to, I hope, to have some context about what conditions have been like recently and sort of risks to think about given the conditions that we have right now. So I'll stop there.
Thanks so much, Vanessa.